Hello everyone and welcome to the last lecture of this course of Principles of GIS or Geographic Information Systems. In this particular lecture we will be discussing 4 subtopics. Those are a small ones, so I have fitted in one lecture. The first one is the limitations of GIS, and second one we will see the rules of GIS. Third one is because lot of new names are coming for GIS. So, is this meaning of GIS, that is Geographic Information Systems, still is meaningful or not, it is relevant or not, that we will discuss little bit. And then lastly we will discuss the future of GIS, where future is going of GIS. So, let us start with the first part is the limitations of GIS. As you know that GIS is not a universal tool, each and every tool has got its limitations. If I give you example, the work which hammer can do, the plier cannot do, and if the work which plier can do, hammer cannot do. If you try to do the work of plier by hammer, either you will injure yourself or you will not be able to execute that work. So, no tools are universal, neither GIS. What are the limitations of GIS? We will see one by one. First one is, it is mentioned that GIS is expensive. To some sense it is correct also, because it is a computer based information system, and if it is a large enterprise GIS, lot of hardware and softwares are required, and that involves cost. So, it can be said expensive, especially compared to simple paper maps, atlas and other way of presenting the maps. So, sometimes GIS is expensive, but let me say one thing at this point of time. Initially it is expensive, but later on it would be more cost effective, because the reason is that initially you have to invest lot of money in hardware or software and expertise which one. Once that setup is there, then now it is much easier and it will become cost effective very soon, because updating of data in GIS is very easy. As you know that GIS is a ongoing and continuous activity. So, therefore, the system or database which somebody has developed can be used later for other applications as well. And since everything in digital format, and therefore, if the data remain within same organization, then the cost will not come there. So, the database development will require lot of expenditures, but later on once the database is there, only updating will be required. So, therefore, in long term it is not really expensive, but still if you just start comparing with paper maps or atlases, of course initially it is expensive. Second is, it is also said that it requires too much of data. It is a data hungry. It does not it is a toolbox, but it's empty initially. You have to feed the data. Every time you have to feed the data, update the data, and everything has to be in digital format, and it is expensive as well. Say for a Survey of India topographical map, it may cost say 100 rupees, but if you go for digital data, it would cost many thousand rupees. So, because digital data is expensive, paper maps are easier. So, this makes another reason for GIS becomes expensive. Once the data is in digitized form, then it is not that expensive. Now, as by definition GIS is a computer based information system, and therefore it is computer intensive, and hence many times have proved expensive, further requires big storage as well, because the data, once it requires a space for data, and the output it will create, that too has to be stored, and also backup system as well. So, it is not that initially it is not that cheaper. So, that is one limitation of GIS. Now, GIS special databases are software dependent, and hence their exports and imports are very limited. What it means basically that somebody might be using first initially maybe the database management system which is available within one GIS software. Now, you are going for a large operations or an enterprise solutions, there the database might be in other form like in Oracle or other. So, now this transportation of data from one database management system to another again will involve cost, conversions, and conversions might bring errors. So that is another limitations of GIS, that it is dependent on the softwares which are handling the data, database management softwares. And sometimes it is also said that GIS solutions are slow. The reason is because if everything has already been organized in a digital database, then the results can be achieved very easily. But if everything has to be developed from scratch, then definitely the solutions will come quite slow. So this is a bad thing which is mentioned about GIS, but initially this thing will happen, but later on, as for the cost, so the speed of the solutions will start coming at the later stage. Once the setup is ready, database is ready, then that issue will not come. And another, because everything is being handled in a digital format, therefore this issue sometimes become very complex, which is copyright and distribution issues. Because if I have bought a digital data from, say for example, from Survey of India, now it is I cannot give to anyone. Even sometimes if I am using part of that data and creating something and giving to something, then these issues will also come, the copyright and other things. So this is this we enter, once we go in the digital format, we enter in a completely complex issues of copyright and other things. So one has to be taking care that rather than just presenting the same data as we are supplied by some organizations, instead if we produce some results out of the data through the analysis, that would be safer and such issues might not come. So this care must be taken, otherwise things may become little problematic. So these are the limitations of GIS, which also one of the limitations is depends on the output device, because ultimately though the data everything has been done digitally, now everything cannot also be all the time presented in digital format. So then it has to be printed. So once from sort of a live map, it becomes a fixed map on a paper, or it has to be only viewed on the computer if you want to see the digital form. Now every time for the decision makers, they cannot come in your setup. So you have to carry, everything cannot be carried. So ultimately you will reduce the information, prepare certain maps, outputs and present to them. So the real feeling of the GIS and the accessibility to the full data set becomes limited. So this is another limitation because of a fully computer based information system. This I have already mentioned in the previous lecture, that error propagation can lead to very erroneous results. One has to be aware, and it's a very important thing is there. So after this limitations of GIS, we come to the rules of GIS. These rules you may not find in literature normally, but these are the rules which are coming through experience and working in the GIS. The first rule is there is no scale of digital data. This looks little very straightforward, very strong statement that digital data does not have a scale, but it is true, because as long as the data inside a computer, or say a map in digital form is in the computer, it does not have any scale. Once you project it or print it, scale is frozen. So that is why this statement is there is no scale of digital data. Now the resolution is a different thing here. Suppose a satellite image which is having 10-meter resolution, if it is residing in my GIS database, the resolution will remain same. It is not going to change. But once I print that one, then the scale is fixed, resolution is fixed there. Because I may print the same satellite image in a A4 size or maybe in A0 size. So then scale will change. But as long as in the system, it will not change. So this is very important to remember, that there is no scale of digital data. Now another thing is, which is sometimes misleading, is also the colors. Colors do not have much meaning except if they have been used for that using some standard schemes. So the values or like a attribute value or a elevation value of a raster matters most, not the color. If there is a elevation of say 200 meter, I can assign a red color or somebody can assign green color. So if I start thinking that red color means 200, then somebody assigned green color, my concept will change. So colors do not have basically any meaning. What matters basically the code or value of the object or feature. Now the third, which we have discussed already, that error propagates in GIS, hence error should be checked at every stage of process. This is standard practice. Let's make this rule is, after each and every operation in GIS or processing in GIS, check for errors. If found, correct them immediately. Don't go for the next step, because then error starts propagating and you would forget to correct the errors. So immediately after each and every step of GIS operations, one should check for errors. Another related thing is here that instead of going for very complicated equations or compound instructions or syntax in GIS analysis, go for simple one, maybe in multiple steps, so that after each and every step you can check for errors. If found, correct it, then go to the next step. Another very important thing which has already been touched in previous lectures, that the 0 is a value in GIS. 0 does not mean no data. So there is a complete no data concept, which is a value which is in reality it is not possible if it is a digital elevation model. So a no data value for a digital elevation model might be a value of say like 10,000 meter. You know that highest point on the earth is 8848, that is which is Mount Everest. So 10,000 cannot be there, and this value we can assign to the computer, it is no data value. So once it is declared that value, the 10,000 in a digital elevation model is a no data value, system knows, and therefore in any calculation, any analysis, it will treat as a no data value, it will not treat it as a numeric value of 10,000. So whereas the 0 is a value, whereas 0 does not mean no data. So this no data concept have to be understood very carefully. You can declare your own no data value, otherwise the system, the standard GIS softwares will declare themselves the no data value depending on the range of values, and this value is so far from real values that system can recognize very easily, and that this is the no data value, not the value or 0. 0 is a value in GIS. This is another rule, that a straight line should not be digitized. Only the coordinates are digitized and then connected. Because if you start digitizing a straight line, you will add few more internodes, and that will never be a straight line. So if it is a straight line, suppose you want to draw a border or boundary of an study area. So just 4 points would be sufficient for a polygon, rather than in between you are digitizing. That will bring errors. And sixth is the never digitize a line, polyline, polygon twice, because no human can digitize the same line twice identically. It will change, and therefore this should not be done. And this is what is while discussing topology, this issue also came, because the common boundary between two polygons should be digitized only once. If it is digitized twice, that means it will fall in this one, a line is being digitized twice. And if it is digitized twice, there will be some gaps and there will be some overlaps, and this will bring artifacts or unnecessary polygons which were never intended. So the topology, construction of topology will definitely avoid this kind of scenario. But if you are not following that thing, not constructing topology simultaneously, then this can become a big problem later on in your analysis. So remember, never digitize a line or polyline, polygon twice. And do not completely depend on export and import tools available in GIS software. That means the conversion tools or save as tools. Sometimes as a TIFF file, save as JPEG, you are losing the quality. or precision also. So, these all tools, all conversion tools, all export import tools are not fully transparent. A DXF file, if you convert into shape file, it might bring certain errors, and once you have done this conversion, check for errors. If found, correct it or change the tool. So, this one has to remember all the time that these conversions are not fully transparent. Export import of the data from one format to another is also not fully transparent. So, once the data has come into the system which was originally in different format, must check for errors whether it has introduced some errors or not. So, these because it might bring certain problems in your coordinates. So, this brings to the end of this particular small discussion on rules of GIS. Now, third one is in this lecture is whether this the term which was originally was given by Roger Tomlinson, which is Geographic Information Systems, is still meaningful, is still relevant. Because after that invention, lot of new names are coming, have been coming, is still coming. Everybody is trying to modify the term GIS to their own benefits or whatever purposes. For some people are writing like instead of writing GIS, they write like computer mapping, land information system, geoinformation, computer graphic, spatial information system, geoengineering, geomatics, geospatial, topographic systems, all kinds of names are coming. But that term is still it is complete by itself and it is still relevant. This is what he also emphasized, that some have different shades of meaning, but the overall term geographic information systems serves still today. This is because it incorporates all the tools, the concept as per the definition, everything is there in this one. So, geographic information system in that way is still meaningful, it is, and there is no need for going for all different terms which might bring some confusions in the user's mind. So, it is a clear meaning, uses real words rather than manufactured words and has a relatively long history. And tens of millions of dollars have been spent successfully putting into the public domain the GIS in recognized worldwide. I can give you an example like GPS. A person might be using data from a Russian network which is GLONASS, but still they will call as GPS. So, likewise here the GIS is still meaningful and relevant, and no other term can really replace the original word or original concept of GIS. You might be having a custom designed GIS and then people have started giving a new name. So, which is a very stripped version of a full GIS. So, though that is giving a misleading information, but it is not substituting or replacing the term GIS. Now, the fourth topic here or the last of this lecture is last of this entire course is the future, what lies ahead, what is going to happen as per today's understanding. It is very difficult as mentioned here. If I really knew what is the future, would I still be here? So, nobody knows basically what is going to be the future, but whatever the present circumstances, present availability of data, hardware, software and concept, we can think something about the future of GIS. If we start looking little past, what we find that basically the GIS presently is being used mainly for managed data, that is spatial data, analyze spatial data and communicate information from one end to another, maybe through net, maybe otherwise. Where future is relatively the importance is shifting and it is getting influenced by the implementation technology. As the new technologies are coming, the integrations with other technologies are becoming much easier and therefore the face of GIS is also changing. Like a few years back, we never thought that we will have a Google map on our smart mobiles, and we will be using that Google map as a navigation system. There were used to be a separate navigation system. Probably all of them have disappeared now, and Google Earth has come. Because the updating is done, it is easier and it works on almost all types of mobile devices. So the technology, as the new technologies are coming, whether it is in communication or in computer or in mobile, so it is bringing its impact or benefits into the GIS as well. And new products, new applications and new usage of GIS will be there. The people, those who are using Google Map, may not be knowing that they are using a special or custom designed version of GIS, but they are happy, they are using. Another thing is that the changing emphasis. Initially, the lot of time used to spend on the data conversion, especially from analog to digital. But now, this data conversion here, it is getting less. That means less time is being spent on data conversion and less resources are being, because lot of now data is becoming available in digital format. 20 years back, this was not the scenario. So this is a inverted triangle in that sense, and that at that time 10 or 15% attribute tagging. At that time used to be spent here, that remained almost same. Then there were less time for spatial analysis or analysis part, because a lot of resources and time were spent for data generation, that too in digital format, in a creating a spatial database. Nowadays lot of data is available from different organizations or on net or otherwise, and that is fully GIS compatible. GIS compatible means compatible to standard GIS softwares. So if you get the vector file, that can be directly seen in your GIS software, or if you get the raster data, you can directly use that one. So this is what meaning is compatible, and therefore in now or in future, people will be spending more time on spatial analysis rather than preparing everything for the data analysis, and very little time and energy were spent for data analysis as in the past. So this is the future, from basically data generation, conversion to now analysis, which we are moving. Also in the past, the emphasis was on the description, now it is going towards simulation and modeling. That is the ultimate aim. If I recall the definition of GIS, at the end it says the model and output. So this modeling is very, very important, because it you can predict something which has not yet happened, and accordingly remedial measures or preparation can be done. Maybe it is related with flooding, maybe it is related with earthquakes, maybe it is related with droughts and so on and so forth. So that is the advantage of having GIS, that modeling can be done. Once the database is ready, as happening now, that lot of data is becoming digitally available. So now from description part, we are moving towards simulation and modeling, and this is how the things are changing and this is the future which we are seeing, that the visual simulation and virtual reality, real time display how, and it must be like forest fire. I will give you this example, or freeway traffic flow, and other informations are available. Forest fire, there are the satellites which are acquiring data almost every day, like MODIS, and in tandem it has MODIS is a sensor, so in tandem it is having two satellites, Terra and Aqua. So these satellites are acquiring data day and night. If somebody is working for forest fire, at least in 12 hours, every 12 hours he can get one image, and these sensors are having thermal channels. So putting a automatic algorithm, detection algorithms, one can detect the fire. With some human interventions, also a plume can be detected in daytime or nighttime data. So that will confirm that the signature is really a fire, and how we can call as a forest fire, because in GIS platform we can have a forest cover map of the country or area. So once a hot spot with plume comes, we are sure that this is forest fire, and accordingly things. So, GIS is going in that way in the real time or near real time. Another thing is that like in this in Google Maps, traffic information is coming. So, that is also almost in near real time. How it is coming, we will see little later, and that comes basically through the density of mobiles which are located there. So, if suppose along a road there are the mobiles are not moving or moving slowly. So, it is assumed that traffic is slow, and therefore, in your Google Maps you see this road network in different colors. At patches you will find red, that means that at that location the traffic is not moving at all. If you find in orange color, that means it is moving little slower, and so on and so forth. So, similar applications are coming which are using the mobile density or population density, and then putting like here the tracked by the cell phone data, and there you know that how things are happening. So, here in at a particular time, this was the scenario that reached to the very high in 10 say at this example at 10:15 p.m. So, that means people were elsewhere during this time and that time, now they have got assembled at one place. So, looking through the mobile density, one can estimate what kind of population density is getting there. Maybe population density of the vehicles, maybe population density of human, but the input is coming from mobile data. So, this is in near real time. This is really not really near real time, it is happening in real time. So, and this is all the outputs from GIS. So, lot of applications are coming which are real time traffic information. I have given the example of Google Map, transportation planning, taxi cab location, retail store locations, and really in the disasters, natural disasters like in earthquake or in flooding which occurs suddenly, especially the earthquake phenomena. And there once such phenomena occurs, the first thing people start looking maps, satellite images, and they would like to have immediately after that earthquake event, so that the houses which got damaged, people are in need, can be reached very easily. So, how to assess? Because once such phenomena occurs, the accessibility becomes very poor, and all those networks, mobile and other power grid and other thing fails. So, therefore, at that time people immediately resort to the maps or GIS product or satellite images. So, there it is really required in real time or near real time information. Now, also the emphasis is changing from 2D to 3D or even 4D. Time is also coming. Google Map is bringing in that way 3D, time is a third component, and some people are thinking to even go for more 5D, 6D, 7D by bringing pressure, texture, temperature, sound, smell all into your simulations and modeling. So, this is the future probably as per today's understanding about the technology and perhaps requirements. This is the future of GIS which is coming. As in the beginning it is said that it is very hard to predict future, but this is what it can be thought at this time. So, past was GIS applied to, this is another future for GIS. GIS was focused mainly on planet Earth. Now, we are moving towards other planets like Mars, Moon. Moon of course is a satellite of Earth, Jupiter and other planets. So, thank you very much, and I hope you have enjoyed this course on principles of GIS. Thank you very much.